Hexadecimal to decimal conversion. In the last lecture, we have discussed the decimal to hexadecimal conversion. Now here we are discussing the hexadecimal to decimal conversion. Maximum, the procedure is same. Now in this location, we are giving the hexadecimal value. Now 0A I have taken. For that equivalent decimal value is 10. Now this we need to get the value. Now this is nothing but what carry. Now when we are converting the, so total, this is the 8 microprocessor is a 8-bit microprocessor. So maximum minimum number is 00 and maximum is what, FFF. Now if we are giving the value here, then that time we trying to convert to the decimal, there may be a generation of generating the carry. Now if you take FFF, if you convert this one, then the maximum number is 256. It is 256. So it is 255. So now that time what, here this 2 is nothing but what, carry. So there may be a chance to generate the carry when you are giving the larger number here, that we need to consider. This is about the data and result. Now how to do that? Again the same procedure. Accumulator I am initializing with 0. Every time I'm adding with 1. So now first initially if I'm adding with the 1, then the result is 1. That time I'm using the counter. Now here also B I'm using as a counter register. So that time I'm counting here. First time count. And after that this value should be converted into decimal value by using the DA instruction. And also need to compare the, now here if you see, after the DA instruction, accumulator is holding the decimal value. But if you see in the location what you have stored, hexadecimal value. Now this value is needed to be compared with the count value. Now counter value is the hexadecimal value. Now accumulator value is the decimal value after the DA. That's why you have to compare the B value with the M value. So now whenever there is a match with the count value and the location value, there we need to stop adding the 1 to the accumulator. Otherwise, this adding 1 to the accumulator should go on. Now the for first value, accumulator is holding the 1, counter B is holding the 1. After the DA instruction also, accumulator is holding 1. So now this counter value is compared with the location value. So both are not matching. Then we need to add one more 1 to the accumulator. So thereby accumulator is holding what? 1. So for that 1, we are adding 1. Thereby what? Accumulator value is 2. This is converted into the decimal. Thereby what? Accumulator is holding again 2 only. So below the 9, there is no difference between the decimal and hexadecimal. Both are same values. So below the 9, no need to bother about the DA instruction. So now here this value is 2. So now here this count 2 value is compared with the accumulator value. Still it is not matching. Then once again, we need to add 1 to the accumulator. Now accumulator is holding what? 2. For that 1 is added. Now 3, like that it is go on. And when it is comes to the 9, so now if the counter value is 9, that time accumulator is adding the 8 plus 1, 9 value, and this 9 is compared with the memory location value. So again not matching. One more time addition is needed to be done. So counter value is A now. Accumulator value is what? 9 plus 1 is nothing but what? A. And after the DA instruction, now the accumulator is holding the 10 value. Now this value should be compared with the memory location value. Which value should be compared? Now if you see, accumulator is holding the decimal value. If we compare with the accumulator value, it will not, never it will match with the memory location. So we have to compare the B value with the counter value with the memory value. So now both are matching. So now we have to stop doing the addition, adding 1 to the accumulator. Now comparison is done. Comparison is done. So now we have to stop adding the 1 to the accumulator. Now where the result is in the accumulator. Now this we need to store it into the next consecutive memory location. While converting, while adding 1 to the accumulator, that time if any carry is generated, that carry should be needed to be stored. So now, but if you see comparison, what I said, comparison should done with the count value. Counter where I have stored counter is stored in the B, memory location B. Now B I have to compare with the memory location M. But in the microprocessor, we don't have the compare B with M instruction. We have only the compare M, that is only done with the accumulator. But accumulator is holding what? Decimal number. But comparison only can be done with the accumulator. So further what we need to do, we have to store the accumulator value temporarily in some other register. Now already I have used the B, and to store the carry I'm using the C. So that's why one more register I'm using to store the accumulator value temporarily. So I have to store the accumulator value temporarily in the D register, and B value I have to move it into the accumulator and do the comparison. After completing the comparison, again the accumulator value, what is the result, that D value should be again moved into the accumulator. Now this is the analysis for the hexadecimal to the decimal conversion. Now we need to write the program for this one. Now for that, initially what I have to do, I have to initialize the HL pair with the 65001. For that, LXI H comma 6500. So now, otherwise you can use the load immediate, that also you can use load immediate, and now that you can't use. Why? Because initially we have to uh, initialize the accumulator with the 00. So you have to use this only. Now again I'm using the I'm initializing the accumulator with 00 to do the addition, and I'm initializing the B to the 00 for the counting purpose. This is for the count. Now next, one more register I'm taking, C register. I'm initializing with 00, and this is I'm using for the carry. So if any carry is generated, now here I have taken A, for that no carry, but if I take some other larger value, now for example, if I take C2, that time carry may generate. So that's why we need to take the carry. So now carry, for the carry I have used this. Now for first what I need to do, I am incrementing the B value, INR B. So B is incremented. Then what, after incrementing the B, what I need to do, I have to add the 1 to the accumulator. So ADI 01 means what? Accumulator is holding 00. For that, if I'm adding 1, then accumulator is having what? Now after that, result is in the accumulator only. How much? 01. Now for that, I need to convert the, this is nothing but what? Hexa value. Need to convert into the decimal value. For that, I'm using the DA instruction. So after that, what? Accumulator consisting of hexa value, decimal value. Now for 1, decimal value is also 1 only. So now we have to, after the one addition, need to compare the count value with the, now if after that what we need to, if any carry is generated, we need to take care of the carry. So for that one, what I'm doing, J and C. If no carry means I am asking to jump to the next location. If carry is generated, need to increment the carry counter. Now for carry I'm using what? C counter. So increment the C. Now here, if no carry means what? We need to compare the B counter value with the memory location value. Now further what I said, counter value directly we can't compare. Compare instruction is only with what? Accumulator. So for that, what? Accumulator is holding the result. This we need to store the temporarily into some other register. So D register I am taking to store the accumulator value. So now after that, what I need to do, I have to move the counter value into the accumulator for the comparison purpose. Now compare M. So to compare M, that's for that, this counter value is moved into the accumulator. Once the comparison is done, immediately we have to move the D value into the accumulator. Comparison is done, then what we need to do, we have to restore the result into the accumulator. And after that, what we need to check whether the zero flag is set or not. Now here, this is after the comparison, Z flag will set or may reset. Now that we need to check here. Now in between we have used the data transfer instruction. Now data transfer instructions will not affect the flags. No flag will be affected by the compare flag. Now compare instruction. Now here, If the comparison is means what, accumulator value is matching with the m value, so we have to stop adding the one, otherwise we have to go on add. No other means what, z flag is z, when will the z flag will set when both the values are same. If not set means what, both the values are not same. So we are asking to jump to, so now here we are asking to jump to the INR B, so that it will increment to the 2, and one more one will be added to the accumulator. So till it will done, till the counter value is matched with the memory value. If these values are matched, then it should come out from this loop and need to store the result, where the result is in the accumulator. So store accumulator into the next consecutive memory location. Now in this location, we need to store the accumulator value. And also if any carry is generated, that we need to store it into the next location. For that, now where the carry is there in the C, that we are moving into the A, and we are storing into the next consecutive memory location. So instead of this, and after that what, halt. So instead of these, you can also say that because LIXIH means what, it is holding the first location. Now by saying the increment X, you can store the A value into the memory. And also by incrementing the X, you can store the carry value into the memory. So instead of writing this, you can also write this. So whichever is convenient to you, you can follow that. Store A means what? Accumulator we are storing into the memory location. This is a direct addressing. This is the indirect addressing. So whichever is convenient, you can follow. This is the program for the decimal to the hexadecimal to the decimal.